Middle East, not Middle Eastern, what am I talking about? Middle Eastern is not the right word. They're European mathematicians, but mathematicians don't have to be European. They can look just like you, they can come from different backgrounds. So Dr. Erica Tatiana Camacho, so she was born in Mexico in 1935. So way back in the day, 3 months after she was born, her father passed away, leaving her family with basically no money. And so first off, right there, I want to point out that she was able to make something of herself without a father, without money, without anything. And it didn't just stop there. She moved to America for her mom's fiance, but they had a rough life. They moved into California, and when they moved into California, East LA, they did not know English. And so that would have been in the 40s or so. In the 40s, people were even less tolerant of someone who didn't speak English, and so they were not able to communicate with people. But in East LA, she was mistakenly placed in an honors English class rather than an ESL or an EL class, right? So if you're brand new to a country, you need to learn how to speak English, right? Be kind of important. And she got mistakenly placed into an honors English class, and what I want you to hear is, that was one of the toughest things she ever had to do. But her teacher worked with her. Her teacher said, hey, I know that you're still capable of learning these things, because they tried for weeks to get her transitioned to an ESL class to help her learn English. But the reality was they didn't make that change at the office level. And the teacher worked with her, and that changed her trajectory. Without this teacher that cared about her, without this teacher that pushed her and supported her to succeed in an honors English level class, she doesn't become someone with a doctorate, someone who goes off to college, period, much less a doctorate in mathematics. And so please understand, if you feel like, man, I am over my head, you're not someone who is learning math in a foreign language, you're not learning English in a foreign language. You can do this. Your brain is like a muscle, and you got to work a muscle out to get stronger. You got to work out your brain to get better. So I need us to not give up on ourselves. I'm here to support you. Ms. Kowalski's here to support you to get to what you're capable of. In high school, she had a gentleman named Jamie Escalante. I think that's how you pronounce it. Apparently they have a whole movie dedicated to him. But one of the things was that Jamie Escalante in high school showed her the power of mathematics. So we're looking at 1950s. Keep that context in mind. Right? 1950s, LA is not a friendly time to anyone who's not white American. It's not. And still, she had Jamie Escalante who showed her the power of mathematics, showed her tough love, challenging her and his other students, her peers, to be more, because you are capable of more. I don't think if I was to do a Saturday morning math session that we'd be able to get anyone here, but I do have those YouTube videos there so that if you want to learn and master these ideas, you can do that. You're capable of amazing things, just like Dr. Camacho. She struggled with racism all the way through earning a PhD in mathematics. So for someone who came from Mexico, who was born in 1935, who got mistakenly placed in an honors English class, who eventually had some cool math teacher that cared about her and challenged her to be more, she studies mathematical physiology today. She studies how components in your visual system eventually will lead to blindness. The very first person to ever do that. And so I want to challenge you at the end of this to understand, you might think you have barriers, but what are you going to do to overcome them? Because you're capable of amazing things. Don't give up on yourself. I have not given up on you. You are capable of growing and learning, but I will say I need you to put in the same level of effort and care that I do, because you can do it. And the other question I'm going to ask you is this: what difference are you going to make in the world? Are you content just moving through life? Or do you want to make a difference? Because you are capable of making that difference. And so we got to get to learning and thinking and growing, right? So think, communicate, collaborate today. With that in mind, Jack, I need headphones off. Deshaun, headphones off. Andriana, headphones off. Jordan, I need your earbuds out, please. Cannot think, communicate, collaborate, can't hit our potential with those things in our ears. We got to think, communicate, and collaborate. So, today we're going to continue with our Trashketball review. One thing I do want to recap really quickly, because this is not going to come up today because we already did this on Friday. What makes a relation a function? What makes a relation a function? The what? So if there's a square, that doesn't make it a function, it makes it what type of function typically? We need to remember, if it's got a square, that is a what? Taj, you said it. Quadratic. That square, so some of us need to go study a little bit tonight. Good thing we're doing some practice today. That square makes it a quadratic function. But I do want to caution you, this would not be a quadratic function. If you were to graph that on a calculator, what you would see is a circle with a radius of 30. So just a square does not make it quadratic. The reason I know this, one, I've done math for a while, but I wanted to point this out. And this will help in the next unit that we study. Notice I just subtracted x squared, because what's anything minus itself? 0. Be careful. Multiplying and dividing creates 1s. Adding and subtracting creates 0s. So y squared is equal to 9 minus x squared. What's the next thing I need to do to solve this equation for y? Y is being what? So squared, raised to the second. What undoes the square? There's something you have studied. Division's the inverse of multiplication. So division and multiplication go together. Those are inverses. Addition and subtraction go together. Those are inverses. What's the inverse of a square? A square root. Now a square root has a unique property, and all even roots do. I want to point this out. I'll come back to this in a second. I just want to illustrate this point. If I say x squared equals 9, what does x equal? 30. Is that the only answer though? Is there anything else I could substitute in for x and still get 9? Not a 1. What's 1 times 1? 1, right? So 3 times 3, that's 9. There's something else that when I multiply it by itself, I get 9.
Is it negative 3?
Say it again.
Negative 3.
Negative 3. Please notice that the square has that unique property that if I square a positive and square a negative, it becomes positive, right? Because of that, when I take a square root, I have to do a plus or a minus. Right? X equals positive and negative 3. So notice this one input is going to have how many outputs? Right. So you can see that algebraically. I just want to point that out because when the x and the y are squared, it's not going to be a function, right? But if it's just y equals ax squared plus bx plus c, it's going to be a function. But we're still missing the definition of a function. We got to know this. What makes a function a function? Samaja, come on. What? Very close. One input for every output. Come on, I need a little bit better language. One input has only one output. Remember, and we have to be careful. It's not just that it has one, because negative 3 has one, doesn't it? But it needs to have one and only one output, right? So one input maps to one and only one output. One input maps to one and only one output. Okay? So you gotta have the one and only one. Okay? Linear functions. What's kind of the key defining detail of a linear function? It's a line. That's only graphically though. There's something else more important.
Repeat the slope.
The slope, which is repeated what?
Addition.
Not just repeated addition, it's constant repeated addition, right? And that constant additive rate of change was called a what? Slope, right? You had that earlier. What about an exponential function? What makes an exponential an exponential? Constant multiplication, right? Constant multiplicative rate of change, called a constant factor. Don't forget your constant factors. And we're going to get some more practice in with quadratics today for sure. Some linear and exponential as well. But don't forget, there are 3 different forms of a quadratic, right? There's 3 different ways to see that square that Tyler was talking about. The vertex form, a times x minus h squared plus k. Factored form, a times x minus r1 times x minus r2. Standard form, ax squared plus bx plus c. Remember, I've said this before, and I'll say this again, and some of us started doing a good job with this on Friday. Every time you write out the equation, that's the equivalent of reading it how many times? 7. If you need to, write out your equation multiple times. Take enrichment today, and just write out vertex form, and then write the vertex form several times. It'll help you. Maybe do that tonight. Do the same thing with linear, the slope-intercept form of a line. Do what you need to do. Write this stuff out, read it, study it, practice it. You need to do those things because it's not just writing out those forms, then identify what those different pieces are. You need to recognize that h and k are your vertex, r1 and r2 are your roots for your x-intercepts. But we're going to get some practice with that today. So, one person per group needs to have an iPad out. Go to our class on Desmos. So y'all talk about it amongst yourselves. Who's going to make sure they have an iPad? By the way, if you have not gotten the code yet, there's the code for this class. You need to log in because only 12 of us have. And you do it at home or whatever. You can always see these activities later if you log into our class and type, and it'll be right there. So there's the code. Oh no, I lied. Yeah, 12 of us. That's what it was. Sorry, I was going to say 9. That's my third block. Okay, if I remember correctly, this is the last one we did on Friday. Does that sound right? Yes? Yes?
No.
Okay. There's one detail with this one that I do want to point out really quickly. And so we wrote this equation. Does anyone remember so first off, which equations could I use in this one? I could use the vertex form. How do we know we could use vertex form? It's not a trick question. What do we need? For vertex form? We need what? Remember, for the vertex form, you need the vertex. Now, could I use the x-intercept somehow?
Yeah.
Yeah? Which form would that be? So, notice, I have both the vertex and I have the roots. So I'm going to quickly set this up. So, roots, I've got 1, 0. And I think it was 5, 0. So my factored form would start out this way. My vertex form, that's the point 5 comma negative 6, starts out this way. Now, what's the one issue in both of those forms? I need the A, right? What's up, Todd? Say again. Yep, thank you. Oh, and that's supposed to be a 3. So I get for rushing. So x minus 3 squared. Minus 6. Perfect. Thank you for catching that. Yeah, so I still need the A. Does anyone remember how I'm going to find that A? Well, I'll say this. First off, is A going to be positive or negative? It's got to be positive, right? Why do we know it's positive, Jack? Why do we know that A has to be positive? Not sure? Okay, so I need you to pay attention. Smaja, do you know why it has to be positive? Taj? Not sure? Lane, you had your hand up. Why does it need to be positive? Notice that we got to remember that parabola is concave up, right? If my parabola is concave up, then that A has to be positive. If A is negative, the parabola is concave down, right? And concave up like a cup, concave down like a frown. And a frown's a negative thing, right? We don't want to be frowning in class or in life. Be happy, be positive, be uplifting. I know, Aiden, it sounds like a struggle, but it's a mindset. You can do it. I just saw you give a little like, when I said that. You can do this. Now, what do I need to do to actually find that A, though? I need to plug in a point. Any point. The only thing is, you can't use the same points that you were already using. So factored form, I can't use my roots. But heck, I could use that vertex right there. So don't forget, f of x, is that my input or output? That's the input, right? Notice I'm saying an input of 3. And when my input is 3, what's my output? Input of 3, output of negative 6. That's what it maps to. So negative 6 is equal to negative 4a because we're multiplying all these things. Don't forget, what's the inverse of multiplication? Division. So you can do traditional division or use that reciprocal, plug that into the calculator, and hey, my A is 3/2. And you just substitute that in. If you were to use the vertex form, doesn't matter what point you use. You just got to use one of these points. I'm going to use 1, 0. So my output of 0 is equal to A times my input of 1. Notice this has a little bit more work, but not a ton. You guys got to know how to use inverses. And we'll do a whole lot more with inverses. So negative 2 squared is just 4. We'll use inverses a lot more in the next unit after spring break. Notice, does it matter how I went about solving for A? A is A is A. It's 3/2. That's my A. So I hope that was a quick little review so that we can talk within our small groups. Remember, the core of learning is thinking, communicating, collaborating. You're in small groups today for Trashketball, so you can do those 3 things. So let's go ahead and get up and let's go to our vertical surfaces and get ready for that first question in this Trashketball review today. We've got about 14 more questions that I have designed to help us prepare for that test tomorrow. Does anyone need an eraser? Y'all got that eraser there? Kings, y'all are going over there. Y'all got an eraser here. Or here, aces, who wants to catch it? There you go. And then Taj, y'all have an eraser. Actually, Taj, that's your eraser there. Eights. You better run like the wind, bullseye. All right, Trashketball review time. Well, aces, y'all ain't ready yet. Anyone have an iPad?
No.
No one has an iPad in that group?
Nope.
Anybody got an extra iPad so that our aces can engage in this? Nobody has an iPad that they're not using? Big yikes. All right, how about this? Sorry, Jacks, can y'all switch with the aces so that the Jacks can see up here, and y'all take your iPad with you. So Jack or aces, you'll be up here so that you can see my computer screen and use that. Yeah, you got your iPad ready to go? I'm just saying I would turn it on and make sure we're ready. Yep. And so remember, when you get a question right and you can justify it, right? The reasoning is one thing I'm expecting on the assessment. But when you can get the answer right and you can justify it, you get how many points? 1. Then we have 3 stations set out. If you make a shot from here, or from there to here, instead of 1 point, you get 2 points. To here is 3, and then all the way back here is 5. Risking it for the biscuit. And hey guys, I'm not the most athletic dude. I was able to get the 3 in the first shot, and I got the 5 in 2 shots. Y'all can do it. You just got to learn how to. Oh, you have an extra iPad? Well, they're already set up back there. We're good. Huh?
Deshaun can't shoot.
Okay. Big talk from a man who also didn't make any shots. All right, question. All right, slide 11. Next question for review. Big yikes. 3, 2, 1, and blast off! Write an equation for this function. Yeah, sure. Yeah. Questions, obviously.
Jelly, when I did my internship, my teacher was. Yeah. But, okay. It's different, huh?
You think that would be a good bet? I would say me, them. Yeah, and then you probably need 3. Do you need 2 professional and 1 personal? Oh, interesting. Let's get some ideas flowing. I like some of the things I see. Say again. That one, so like there's one here, but I can't quite tell what that one is. So this really close to the grid, but I don't know what that one is. But what about this direction? Do you see any that is perfectly on that grid? I will say this, y'all got all you can out of that. What can you do from here though? What do you know about that function that gets you there on this one?
I knew you were close, it was just figuring actually. I've written out what each it
Y'all talking about some, I see some ideas going out there. And I saw y'all talking about earlier, but keep talking.
is. One you said is 30. It's 30.
So I'll say this. Alright, that's all you need. What else do you know about this function?
Unless we. For some reason I have it slow, but I don't believe it.
It is,
You're a little bit closer. There's nothing that we know about
every place is
this,
different.
just based on that graph.
So,
Heck yeah, it's not linear.
What is
So
it,
that's
every
good. It's
place?
like, we gotta start thinking along those lines. If it's not linear, what is it? Go back. Okay, so what is it? Exponential, 30.
Then you go down, it goes
Which one is it?
20 and 1.
First one, what are the 3 types of functions?
Hey groups, real
What are they?
or
10 and 2.
shut my hand in front of it. Real quick, is that your X and your Y?
Right? So which one is this?
Like, double check which one's your X and which one's your Y.
Okay.
That's my brain.
Keeping along those lines.
Okay.
I will caution you, don't think it's the exact 13. The only perfect points are 0, 30, and 120. But
I said 30 divided by what is 20?
wait, that's the y?
So,
What does an exponent indicate?
You know, other one.
Do you know anything about this?
I already got my
Right?
30.
So it's here to here. We get to here. Keep thinking. Hey guys, I want to pause us to put us a little bit closer on a level playing field, so pause and listen. Look, we've already established all around the room what type of function we're dealing with. Exponential, we got to know that. Most of us already have the equation, a times b to the x. And I'm not going to tell you any other things other than this. When I look at it, if you know it's exponential, what type of rate of change are you looking for? Constant what? Multiplication, called a constant It is a constant multiplicative rate of change, but it's called a constant what? Factor. You might want to indicate where that constant factor is on that table. It might help you figure out a way to find that constant factor. Let's pick it up. Let's go. I like that y'all started a table, but have you taken any points and put it on that table? Okay, so we got a 0 to 30. What else we got? You can take some inspiration from others, do it, but come on, let's go. Hey, here's a better marker.
Put it in the calculator.
Smile. What is that in your front pocket?
Let's see if you get 20.
Smile. Okay.
Give me that minute.
One equals 30 times 106. Miss Clausen. This is right.
We do have a winner over here though.
Did we already have a winner?
Yeah, we have one right here.
All right. So,
Check your
2/3.
what is that, 9s? 8s? So, if I can get everyone to come over to this board, 8s, I need y'all to explain to us what you did. To the front.
Oh, it's 2/3. 7/3.
Yes.
Almost there.
6 left.
All right, so Izier's over here to learn and grow. So a lot of us were there. A lot of us recognized it was what type of function right away? Exponential. How do we know it's exponential, by the way? Is it what? So it curves, not just a curve. We can't call it a curved line. It's what type of curve? What's the name of that shape? Remember, this is the one that's not tricky. It is what it is. It's called what kind of curve? It's called an exponential curve. And so, Bree, talk to us about what you did from there. So whenever the x is 0, that tells us our what? Y-intercept. A lot of us got there. We got to 30. It was from there that we need to be careful. But what are we going to do from there? One word of caution I want us to think about. You have an F here. Where's your F up here? Where's that F supposed to be? Behind the 30, right? Because the idea is that we're taking 30 and we're doing what to it? Multiplying it by the factor to get 20. And then when we do this, so you had that right. 20 divided by 30 just comes out to be 2/3. Now you just put that in for your constant factor b. Really quick, Bree, just a point, and I know we let it go here, but be careful, because this is not 100% right. Technically, right now, it's only 2 to the x, not 2/3 to the x. How do I make sure that it's 2/3 to the x? I need to put parentheses. When you have that fraction like that, make sure you put parentheses there to indicate that it is the whole thing being multiplied. So you got your shot, you got what, 3 points? So what is that, 8? 4. What? No. You upgraded your 1 point to 3 points. Not 3 more points. You upgraded your 1 point to 3 points. Alright, let's get the next one going. Get ready. Go ahead and erase your board so we're prepped and ready to go, unless you want to leave that. That's not a bad strategy at all. By the way, Adriana, Jordan does have, yeah, you can erase that. I was saying, Jordan has that eraser right there that you can use. Everyone got their boards erased, got their iPads out. 3, 2, 1, and go. Real quick, word of caution I want to give y'all. When you do a table, make sure you do X and then Y. It's inputs and then outputs, right?
Done.
Talk to me.
Well, rise over rise, over three, y intercept negative
I need you to work on that explanation. You get one more chance to explain it. So let me repeat what you said. Rise over run is 2 over 3.
Oh, 3 over 2.
Okay. So how do you know that? Because I need you to be able to show it in a
It
second.
goes up 3 and over 2.
Where?
If you go up 3 squares and over 2,
How do you?
get your next point.
There's a little bit more I'm going to talk about. I want you to pay attention just to be careful, okay? We do have a winner. Let's talk about it. Let's look at it. Okay? So don't erase it, don't erase it, don't erase it. I need us to pause and look at some things. So really quickly, I need y'all to be careful. 0, -3, 0, 2 would indicate we have how many y-intercepts? 2 intercepts, right? Which of those points do we have flipped? It wasn't 0, 2, it was what? 2, 0. Be careful with your x and then your y. 2, 0 would make a lot more sense. So I'm going to get the aces to come up here and explain what they did in a second. But I do want to point out, could you make a table here? Yes, 100%. All right? But, so listen on this, right? We could make a table, and if I was doing an exponential, I would definitely make a table. But what type of function was this again? Linear. We need to recognize it's a line. We're using what equation? Y equals mx plus b. From there, can you identify b and m from that graph really easily?
Yes.
So do you need to make a table this time? No. Could you? 100%. Will that help you on a test? Maybe, right? But don't forget, if you have a graph of a line, that makes your life easy. Man, y'all were right there. All right, so Tyler, talk to us about what you did.
First we found our y-intercept.
Is that the first thing y'all did? I saw y'all do something before that.
Get out the equation.
Okay, do that for me. Right? Remember, what's the first thing that you should do? Write out the equation. Writing out that equation should be a trigger to say, hey, these are the pieces that I need. So the first thing you identified from there was what? The y-intercept. First off, Jaden, what letter represents the y-intercept in y equals mx plus b? B. And I will point out, what's always the easiest thing to find? I would say the y-intercept to me, I don't even have to do anything. It's right there. Be careful, because I did see, I don't remember which group it was, but I saw one group doing a +3 for that b. Be careful. How do we know it's a -3? It's going below, right? It's down. Okay, so talk to us about the rest of it.
We just counted from here at -3. We went from 3 to 2.
Okay, so one thing, so y'all just count it, but I want y'all to see this. If you draw this, this could be even stronger evidence of understanding. I'm going up, so am I adding or subtracting? See how I even put the little arrow on there? It's not just going boop, boop, because I know some teachers do that where they like do a little curve from one to the other. That shows me exactly what's going on, and then +2 because it's to the right. Did I have to use those 2 points? No. Did I have to go in this order? No, see that's still +3 and then +2. But heck, I could have gone from here all the way down to here. Not that I recommend it, but you could. So that would be down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to the left, 1, 2, 3, 4, 5, 6. And I will say, that's my rise. But what's another phrase that you've heard us use for rise? Change in, I would say that's a y direction, isn't it? Up and down? That's going to be really helpful on our graphs, or on our tables. -6 is our change in x. So you know what -6 divided by -9, or -9 divided by -6 comes out to be? 3 halves. 3 divided by 2. Notice there's lots of ways to do this. Make a table if you're comfortable with that. But you can see the slope and the y-intercepts right there on that graph. Y'all ready? Oh, someone needs to take a shot for the aces. The aces are now on the board. So y'all got 1 point for sure. Who's shooting? What? How far do you want? You want the 3? Okay. Little hard. Okay. Maybe someone else try it next time. So, erase your board so that you're ready. Looks like everyone is a little ready. We are starting our next one in 3, 2, 1, blast off!
Oh, table.
Oh yeah.
I don't.
I made my life easy. I didn't want to make it terribly difficult. Yeah, I just stole problems from other practice, so I didn't make whole anything. It's still gonna be thinking, right?
81/4.
Guys, see that y'all have two equations there. Which one do you think we're gonna use? No, can you figure out which one you're gonna use?
Yeah.
Okay, I thought you were gonna take your words.
Zero. 27 and 2.
I can't help it if no one's gonna talk.
What was B again?
So what you have?
Kayla, what do you have? What are you thinking?
Not constant, what?
Yeah.
Okay. It still could be constant.
Or it could be
Their numbers?
Check it.
Yeah. I just leave this as is. If we're looking at a table, what do we know, looking at this, what do we know it's not? It's not linear. So what could it be?
7.
You don't have to. I would even make it fraction.
Exponential. How do we find
3 to
out
4.5.
if it's exponential? What do we do?
4.5 to 7.
Okay, so not constant.
Divide what?
You're gonna have to. So it'd be 7.
Yeah.
Did you check to make sure it actually is constant? You got
That's what I'm gonna point out.
Second, I would say yes.
This one is.
Write this point out so we don't have.
So work together to figure out the equation, that's what you do. And then figure out which component that is in your equation,
7.7.
whatever else.
No, this one's 2.
Okay, there we go.
3.
There's some good ideas.
And then
Let's talk about this one.
5. Another 2. 2 there, 3 there. Yeah, that could be.
Yeah, what?
So if you do.
So, what are y'all thinking?
If you do.
What this is? It's something. It's definitely something we studied, so I'm asking you to write the equation.
Alright, what do you guys think?
What
do we have?
Well, what did he say?
Did you check my drawing?
Make sure you put that in multiplication.
Check your
That's
equation.
what you're saying.
That's
And then it looks like you're multiplying 1.5, make sure it's a decimal. The decimal goes to the bottom, the 1.5, there you go. Hey, y'all good? Come on, keep it going. You know, that's some ideas going here.
Look away.
I'm still around, this thing, hey.
Remember,
We're
just
just
pick
saying,
up the
hey,
calculator
Don.
and check what that is.
How you been, how's your mom been?
Let's try it. Remember, y'all can be, I can't tell you that, but that's what you get when you do 6 times 140.
No, it's not.
Okay?
Okay, so.
Close enough.
Actually, that changes.
I stand by it.
6 times 9.
You did great, like times up. So what is times F gonna equal?
We put 9 times 1/16 to the
It's gonna equal what?
Why are you using that?
What
Because that's
each
what
of these
we
components
do.
mean?
This is what we multiply. So each I need you to understand that this is
We have a winner.
Oh,
They flipped it.
3/2.
we almost had the kings slash, what were y'all, fours get there. Alright, so I need us to pay attention to this. So, I will point this out. First off, we had a table. Did anyone take time or think through making a graph for this?
No.
Could that have helped us 100% know what type of function it was?
Oh, yeah.
Yeah, guys, don't forget, like, if you have a table, there are some good elements of a table, but you don't have to stay in that table. You can make a graph, okay? And I do want to talk about what you did, Deshaun, in a second, because I think I have an idea of what you did, and I want us to see the way they did it to find out what's happening. So how did we know it was exponential? What was the first hint? Now be careful with that language. It's not just about repeated addition. It's not what type of addition? Constant addition, right? Be careful because we got to have the idea of constant, because you can have repeated addition that's not constant, like with a quadratic function. Was that linear additive, right? No, not the same difference. What does the word constant mean? It means it stays the same. But a linear additive is adding, but at a linear rate, not a constant rate. It is different. We gotta be careful about that. So, first things first, it is exponential. We know it's not linear. We're gonna talk about how we know it's exponential. And Deshaun, I really like the way you did it, so I'm gonna talk about that in a second. I encourage it if we don't remember this strategy. So, what did y'all do? And this is what 8, 9, y'all started talking about. Jax, y'all were right there, so guys, keep your head up because a lot of us are still in this. We're right there to figure this out. So, Bree, talk to us about what you did.
basically
Say that one more time. Basically, like what? Oh, yeah, what we did last time, right? Once we think it's exponential, we can write an equation. What was the equation you wrote? No, before that. The top equation that you had.
This?
Yeah.
4 times
Right? A lot of us were doing that. 4 times our factor has to equal 6. Remember, you can use a variable to represent something you don't know. And then, so what did you do from there to find that factor?
multiply both sides by
1/4. Which, by the way, Jack, multiplying by 1/4 is the same as dividing by what? This can be helpful, and you just pay attention to this. Multiplying by 1/4 is the same thing as dividing by 4. By 4! Guys, don't forget, what does this fraction bar right here mean? Division. So it's times 1 divided by 4, right? That is just division by 4. Okay, so I need to pay attention to that. And so you got F is equal to what? 3/2. Now, I do want to point out, you didn't write it up here, but y'all do have it written, all 5 equations. Notice you write 5 equations out, it might help you. Y equals A times B to the X. Now, what was the mistake y'all made from at the beginning? Flipped it around. And so you had 3/2 here times 13.5 raised to the X. Does anyone know why this is a major issue? Like, obviously it has the same 2 values. It's not what we're what? Right, remember, what does an exponent mean? Repeated multiplication. And when that variable is an exponent, that means we're constantly multiplying. Is this function constantly multiplying by 13/2? Or 13.5? No. Right? What was it constantly multiplying by? 3/2. Alright, I'm going to come back to something else in a second. But, Deshaun, you didn't do it this way, did you? Well, how'd you do it?
So there was
how'd you know it was 1.5 though? Did you just know it was 1.5?
I mean, I did not, 4 by 6.
Oh, so you just kind of did the 4 divided by 6?
Yeah, I wanted this.
Gotcha. Did you do 4 by 6 or 6 by 4?
I kept going down.
Okay,
I was just saying-
so you did that, so you did 6 divided by 4, and then you just checked and went through, right? I will point this out, like you can use some logic here, so I want you to notice, if I were to do 4 times 2, what would that give me? 8, right? That's more than the 6, so my factor had to be less than 2, and I'm not going to give you terrible factors. So I want you to think through logically. I was thinking that you just kind of guessed and checked until you got there, but that's also a valid way to do this. Last thing I want to point out then is this. You actually could have made your life really easy. Oh, actually 2 things that I want to point out. Guys, don't use decimals. Just leave it as the 27 halves.
Okay, told you.
Times 3 halves. Hey, it's mathematically perfectly fine to use the decimal, but you don't have to. Just leave it as a fraction and make your life easy. The reason why, I want you to think about this, 9 times what gives me 27? Oh, 9 times 3 gives me 27? And then we're dividing by what? 2. If we just looked at that, it might have told us a lot. Does anyone know what 27 times 3 is?
81.
It is 81. And what times 2 gives me 4? Oh, so I had to multiply by 3 and divide by 2. Strategy, it's helpful, right? Don't forget, nice, we got a 5 there. Don't forget, yes, you can do times F, but sometimes just thinking strategically can be helpful. All right, so 8s, right? They're up to 8 points. May have to change up groups after this next one, depending on how the points fall out. 3, 2, actually erase your boards, get ready. And I do want to remind you, I know that the 8s got that one, but several of us were right there. So everyone can still get those points. It just takes 1 5-pointer to get up there. 3, 2, 1, blast off!
Or it only matters if input. Input equals.
Make sure y'all are thinking about what you think, figure out what's going on here.
What you did last time.
It's not 2 negative 3.
Use the, big AX squared.
No, what you did last time. Did you do
Type that into the calculator for me, Audra.
Yeah, put that in your calculator.
What does it say? It says undefined, yeah.
I figured it was like, this is zero.
I thought we talked about that earlier, but.
You can, real quick, you can't divide.
Put it in your case so that it's not out at
That
all.
does make sense. It like mathematically does make sense, and I want you guys to think, can you multiply anything?
So I will point this
from
out.
zero to get to
Notice
zero?
that's undefined.
No.
You know what that tells us?
No, it is something, it is a function.
Plus 4.
You can do those
Plus
two,
four.
but then is it
Constant
constant?
factor.
I don't
That's a good
know.
thought. So what do I need? So
Yeah.
1, you can't
Okay, that's
okay,
pretty easy.
all right. So what's happening?
Okay.
Oh, that's where exponential is 1.
Mason and Bree?
Or exponential.
That's
Or
one.
This is
no, y-intercept is Huh?
Well, current charge,
No.
super distance.
If it was linear, that would need to be what?
Graph it out.
All is,
Hey guys,
yeah,
I
so all
want to take
negative
one
through, so it needs to be what?
We've talked about this before.
We have both
Is that the
centers
easiest
set,
way to do
so
this?
we can-
Oh, yeah.
What's it
Probably
called?
not, right? What would be the easiest way based on this table?
This would even constant x. It's
All one
Why?
and
Isn't it flexible?
it's not linear, and it's not exponential.
I'm looking for a small.
That's constant additive. What type of function has a constant additive rate of change? What type of function has a constant additive rate?
Y'all got this. They need that. Guys, they need that.
Just an open application. He is.
Hold on.
My question was, what type of function has a constant additive rate of change?
One, three, negative one.
Starts with
Then
L.
y, the y is up to be six.
What do you call that? What do you think?
So you should negative.
So this is not a
And
function,
then another one would be
but it is
negative one.
linear. And what do we do with that linear? We are, do you remember what type of function has a linear additive rate of change?
I want to say that y today is y equals a. X minus R1.
Linear, exponential.
Right.
You did that zero equals something something.
No. Write out your forms, think about it. Is it there?
We need help.
No, we don't.
No, we don't, never mind.
Go this time.
That's what it
Think about that.
Have your board.
That's what it says right here.
And that's lost.
One thing I'll point out is, and to remember is this. This input should map. Okay? Have you checked to see if that that an input is 0 maps to 6?
This is wrong.
Well, this is
There's one
what?
key point you're missing right now.
So you
Think
look
about
at x, and that's gonna be.
It's not right.
Yeah, make it quick.
Y. Well, I would do.
But you got three.
My equation here. But maybe you're on to something.
Think about
Check
that. Guys, think about your form and your points.
What do you do with negative b over 2a? What is that?
Ms. Kowalski,
Think about
did
that.
Jordan ask to go to the bathroom?
Yes, he did.
Only one at a time. We need to cut out.
So this should be
Why?
Over 2a.
Tell me why it needs to be up.
Because
Just remember, it's always supposed to be opposite.
So is that,
no, that's after
is
you
that a
change
plus
it.
or minus though?
That's
Yeah, we just changed it.
Well, that's a multiplication.
You flipped it down.
That's all I'm pointing out.
What?
One thing I will point out is this.
Oh, you. Sorry, no, I can't. I didn't think you said flip. You worded me. Why? Why? Why do you do that?
opposite.
Where do we
Why?
opposite
Because
stack?
because the x is in front of the
Is
point.
it A, Y?
Why though?
Because when you place it down, it
Where
changes.
do we always
It's
have a
supposed to be
minus?
negative when you place it down.
What do you mean?
So like, when you place it in black, it's supposed to be negative.
So we're just gonna do.
What do you mean?
Do I have a minus here? Does it look like
No, no.
Here?
When you put it into point, it swaps places so it goes to
Not
the
just with
positive.
inside
That's
parentheses.
why you go ahead and make it a positive, because it'll switch to a negative.
No, that is not why.
Once you graph it, it's supposed to turn to a negative.
The x. it's
And what
not
is your
inside.
A value also?
It's not inside the parentheses.
Four.
It's plus.
No way.
No, no, I'm
Why
not saying
isn't
this
it
is
there?
wrong, I'm just pointing out.
Because we thought we were wrong.
Plus or minus. It's
You are wrong,
always a
but I need you to
minus.
figure out
Yeah.
why.
You
Why,
inside the
if
parentheses,
it's
yes.
-3, do you put in a 3?
Back up, go.
Is that it?
So we're right, we just need to figure out why.
No,
Why?
She's saying why.
Why do you need the opposite?
I'm saying something.
Think about it.
Yes, and why.
What are the properties we
It's a
know?
group.
Something here.
Hold on.
Positive.
What are those things?
But it's really only.
So what does that whole function need to become?
I'm gonna talk about this as a whole time, I want us to decide it real quick.
Four. Is this one, is this one? Is that-
No, guys.
have plus addition, we always have subtraction.
What is always true about
And we always have
intercept the
subtraction, it's quadratic equation.
That's up to zero.
what is zero?
No, for x intercept y is zero.
I mean, why?
So, why do we flip that sign?
Point to where we see addition in those.
Think about that.
Oh, to get, oh,
And
so is it, so,
where do we
We
always
put the
have
different
subtraction? Page, where else?
Don't we have the root there?
so you can, oh, so it can, yes, is it zero? So it could be zero.
Who's gonna get
I
winner?
knew that.
What? Kings?
What?
Or aces?
What? Wait,
Kings.
You guys were able to
We do
justify
not
what you
have a winner.
only miscalled.
That is not a winner.
why not?
That equation does not work. Check your inputs and outputs. A 0 should map to a 6. They would not in that case.
What?
6? Where do you see a 6 at?
Isn't 0 comma 6 a point on that table?
Yeah, it is.
So 0
Oh,
should
I
map
see
to
the
a
tiny
6.
thing. Yeah, I'm getting it right.
Hmm.
Yeah.
No, no.
What,
Where did
what
you
numbers do you
subtract?
have in there? Read this equation out to me. What, your equation, read your,
When you have x, you subtract.
What? That's not.
Have you figured out what the zeros are to put into there?
guys, justify why those have to be flipped.
We didn't get right. We have to have
So are we still right? We just have to check.
What should 0 map to?
Or x
She just said it.
Check to see if it just.
They have something else wrong.
They have, hey, they can justify it, they gotta win. How come they're listening to us?
Why do you flip the signs? That's all you need to figure out. Look through your notes, talk to each other.
But isn't it just- Okay, if this is right, and this is right, what must be wrong? Think about it, how are we gonna find it?
Come on. If it's wrong, we're gonna
She
zero.
just said it's right.
Wait, wait, hold on.
He just told it.
He said zero equals Oh, yeah.
Or is it or-
That's the exact same thing we did.
We have a winner.
Two.
Yeah, we can.
It was six.
No, we don't.
Oh, we don't?
That, we do not have a winner looking at my equation over
You
there.
said zero.
They just changed that to zeros.
Oh,
They
it
were,
was supposed to be.
like, literally just did to show me that. I
All
promise.
So, we're gonna switch up groups after this one, so get prepared to change groups. 1, go ahead and shoot, and 2, I'm gonna explain a couple of things that I want us to pay attention to on this one, okay? Alright, so what do we at, 11? Yeah, we need to change the groups at this point. Ms. Kowalski, if you could collect cards and go ahead and start changing up groups while I talk about this, that'd be great. Alright, so first things first.
She's the reason why you're winning.
I saw a couple of us doing 0 times f is equal to 2. And this is good. This is something to think about. First off, consider this. But in this case, you're going to have to divide by 0, right? Adriana, what did the calculator spit out when you typed this in? Undefined. You know what the only number you cannot divide by is? 0. You can't divide by 0. So use that as a, oh, okay, so we cannot have an exponential here. But, hey guys, did anyone take the time to make a graph?
No.
Okay, don't do that. Look, -3, 0, -2, -2, 1, -1, 0, 0, 1, 2, 3, 4, 5, 6. And because of the idea of symmetry, I know it's going to be -4, 6. Man, what is that? That's a parabola. Very quickly, I could know that this function is... No, parabola is not a function. Remember, parabola is the shape of a quadratic graph, so keep that in mind. A couple of things I need us to also remember, because this could have been a huge hint. Right here, what do I have? two x's, two x intercepts. So I have two roots, I have two zeros, right? I need to recognize this. Last detail I want us to notice, and aces, I was really glad to see y'all looked at this. Remember, a table is great to see a rate of change, yeah? Yes, Mr. Kenny. Thanks, guys, yeah. A table is a great way to see a rate of change. Hey, this green right here is what type of rate of change?
Constant additive rate of change.
Constant additive rate of change. We're constantly adding. And what type of function had a constant additive rate of change? Notice again what, Jaden? So this purple right here, that's not a function, but it is linear. It is a linear additive rate of change. And hey, what type of function had a linear additive rate of change? Right. So we had a quadratic. So a couple of things that I need y'all to pause, I need y'all to see. So that was quadratic. Right here though, I talked about this with a couple of groups, and I need y'all to note this, because this is throwing some of us off. Please notice, in purple, I am circling where we add. In green, I am underlining where we subtract. When do we always subtract in these equations? Hey guys, I'm trying to teach. I need y'all right here. When do we subtract in these quadratic equations? With the x. When it's x minus r1. When it's x minus r2. When it's x minus r3. I need us to pay attention to that. The subtraction is always the inside of parentheses with the x. Finally, right here, I have roots, and I need us to be careful about this. If I subtract a -3, what does that become? A positive. X, so I have y equals a times x minus -3, x plus 3, minus -1, so x plus 1. Remember, when it's that minus, I need to get the opposite. Now, did y'all just guess and check to find that a?
Yes.
Yes?
Yeah.
Yeah, that's silly. Don't do that. You're making your life harder than it has to be. I kept pointing this out. 0 and any point. What does 0 have to map to?
6.
What does 1 have to map to?
16.
So if I plug or substitute 6 in for y,
Then now you have to divide.
then I have to substitute 0 in for x. And how many unknowns do I now have?
1.
I only have 1. I have a. I can solve that. Or you can just look at it. 0 plus 3 is 3. 0 plus 1 is 1. And what's 3 times 1?
3.
Hey, what do I need to multiply by 3 to get 6?
2.
I'm just writing an equation. A is 2. You can divide by 3 if you want, but done. Y equals 2 times x plus 3 times x plus 1. No one went this route, but I will point out, does anyone know what point this would have been? -2, -2?
Vertex.
So did you have to use factored form here?
No.
No, you could have used vertex form as well. All right. So everyone's got their new groups, ready to move. Y'all each get a piece of candy afterwards.
4s are here,
Yeah.
aces are here, 8s, 9s,
And jacks. So it's just
4s in a red spot.
yeah. Oh, and then aces up here, right?
Jacks are up
Because remember.
front. Aces are back here.
Okay, yeah, we'll let aces go back to there. So everyone should have an iPad. What's the only group that doesn't have an iPad?
Are you gonna move?
Every group has one now.
What's 4?
So I'm gonna record it. It was
Yeah.
Kayla.
No, 4s
Marie.
are where the kings are.
And who was Mason, right? That also got
What?
candy.
What's your an
So
8?
don't forget to grab your candy after class. All right, next round. The next question goes up in 3, 2, 1. Blast off. You don't have an iPad? You all have an iPad though, right? Can y'all switch with the 9s? So the data.
We just didn't have it.
Oh, go. Okay, I got you.
We got after?
All right, please notice table and graph.
You
I
guys
need
don't
y'all to
have
work on
an
this.
iPad?
No, we don't have no iPad.
Okay, so look right here. Y'all gonna switch after this round. So go ahead and look up there. I need a table and I need a graph.
Lane, talk to your group members. I'm sorry.
Hey, Lane, I need you to change markers with Adriana, because I need y'all talking.
Huh?
I need y'all talking more, so I want Adriana to be writing, and y'all need to talk with her as she puts stuff up. I don't want one person dominating it. After this round, I want you to change markers as well, but hold on a second. I just want to point this out. You understand that you have a grid already made, right? You use the grid already there. Make your life easy.
That's why
We
we
all
want
need
these
to look
flipped around, and that's why these are up.
at your stuff a little bit better.
To make it easier for you.
The three of them, negative 3 of the horns are all over wrong.
Oh.
Hey guys, can I pause for y'all for 1 second? Because every group's doing this. Hey, pause. Eyes here. I need y'all to recognize Miss Kowalski and I intentionally put the grid side of the white books out. Use your grid when creating a graph. Stop trying to make your own lines. Like, use the grid there. Give me a heart attack.
Yeah, you see how.
Cool.
Maybe we got some. Don't break that line.
Now talk with your new group.
You get entire, no, while you move the table up there, you get the entire bottom part of the graph.
Why do y'all think 4 maps to 3? You quickly point out, your input is 4, right?
I need a refresher.
I don't think that's going to match to 3. Look again. Yeah, good. Huh?
9 map. I know. Are you max to 9?
I'm blind.
Yep. Let's go out.
I'm legally blind.
What?
3 map for 9.
Okay guys, let's think about this. What's your function?
I was looking all around.
We
Write it
calculated
out.
this? Okay, talk to me how you figure this out. And just make sure you draw it.
But line is 9,
The whole function
out of 9, and then it's.
How did you know the y-intercept was 9?
This is why.
equals y, right?
This is why you
Okay.
just input.
So
Just
what
explain that real
is,
quick.
Well,
X is our Y.
it's y equals mx plus b.
Okay,
So this is b y intercept.
okay, there we
If we were
go.
to
So like,
put
these
X
are
in the
things that
equation,
you
it's
can
the
put,
To show understand.
right.
So, and I knew, and I saw the
on our
negative.
X.
So I
What is
automatically
this?
knew
What is
that
9 gonna be?
-3 instead of -4.
Okay.
A Y intercept. One point we immediately know is
And
what?
so I counted 3, down 3, over to the right 4.
Okay.
what's that point?
And then, did
Okay.
you just use those points to
Write
get
that
that
in
table? Yes. Okay, so I'm gonna talk about it a little bit more in a second, but I do wanna point this out. That
Now,
also means that
I want us
4
to think
needs to
about-
map to what? 6.
what if
So
my X was
Could
1?
you have
How would I
substituted 4
find
in
my
to
Y?
get that 6? Yes. It's 4 divided by 4.
4 9.
1. That's correct. You can use
How
negative.
would I
That's -3 plus 9. 6. Uh-huh. So that should make sense, right? Alright, we got a winner! Aces! They're getting a point!
Alright.
For the sake of time, I'm going to go over this with what they discussed, but I want us to see some details to make our life easy. So I will point this out. Can you always extend your graph a little bit? Sure. Because at least right here, my maximum is 6, but Lane, you pointed out that my y-intercept is what? 9. Guys, how do we know that our y-intercept is 9?
This is a linear equation.
Okay, so I need a little bit more than just it's a linear equation.
Then linear equation. To be a linear equation.
There we go. Y equals mx plus b. It's a linear equation. Notice we can write that equation out. And when I do that, hey, there's my y-intercept. Okay? From there, what can we do? What did you notice, Lane?
that the slope was -3/4.
Okay. So how did that tell you? What did that tell you?
It would go down 3 and then to the right 4.
Go down 3. 1, 2, 3, 1, 2, 3, 4. Guys, notice we have a grid already given. 1, 2, 3, down to the right. 1, 2, 3, 4. And so now if oh, that was terrible. By the way, on the test, I have rulers. Use your ruler to make your line so that it doesn't look like a crappy line. Okay, so we have our line, and what y'all do from there to get your table?
Oh, just use the points.
Use those points. Now, do you have to make your graph first? No, you definitely don't. Now, one thing I do want to point out is, Lane, you said that it had to be -3 divided by 4. Does it have to be -3 divided by 4?
No. Because you can do, because if you did +3, -4, you could go up 3 and then to the left 4.
Right? Notice you can do it the other direction as well. Now, we'd already kind of capped out that height, that upper piece. Last thing, or not last thing, two things I want to point out here is, look at our table. What's the change in Y? What's the change in X? +4. Noticing that we're dividing by 4 could have made a huge difference here. Last couple of things with this one I do want to point out is this. I saw some groups flipping things around, but don't forget, I can always substitute things in for X. Inputs in to get outputs out. Notice, if you don't see the y-intercept, if you don't see the slope right away, can I substitute a +4 in?
Yeah.
Could I substitute a -4 in?
Yeah.
Yes. Could I substitute a 0 in? Yes. You can use that to help you find this table and this graph. The reason I do want to point out that I'm using multiples of 4 is because I'm dividing by 4. That makes my life easy. Notice, what does 4 map to? What does 4 map to? 6. You do it any way you want, but we got to do that. All right, moving to the next question. In 3, 2, 1, blast off. Actually, I'm going to skip that one. I'll come back to it later. I want you to work on this one.
I didn't make any.
I can
I'm erasing, I'm erasing. I thought y'all got an iPad.
No, remember they're switching the kings and the
Oh, they're just gonna look right here, that's right. Who got that one? Y'all did.
Mr.
Take a
I
shot.
already did, I missed.
Okay, so 1 point for Aces.
Small. Maybe smaller than the average. Create a table and a graph.
Come on, Tyler, talk.
He's drawing 2 0.
Okay.
4 0. Ace 2.
So this point right here.
Yeah. But we don't know the X. It could be on
Hey, so what are y'all debating?
Trying to figure out what X is.
Well, X is a variable. So I will point out, notice y'all have, what is that point down there at the bottom?
Check that
Yeah.
again.
2 to 1.
Well, I don't think that's
Okay,
two.
we're down the wrong path.
Or negative 2. 1.
Mm,
Negative
2.
Negative 3.
Oh, negative 3, negative 1.
Okay.
I wanna see about what
There you go.
form we're in and what key features.
How do you know
we
it's
have.
negative 3, negative 5?
Okay.
Or did you assume?
I assume because it's positive contrast.
What key features
Okay.
do we get?
So I'm good with that idea, but I do want to point out, that means negative 3, if I substitute it in, would have to map to what?
So let's work with that first.
No. You said it was negative 3, negative 1.
What are the?
So what does negative 3 need to map to? Negative 1? Did you actually substitute that in to see what it maps to?
No, no. So I could do.
Could you?
So I can do.
I mean, not a key
Use
feature.
that in your table.
What are these right here?
You can use that.
Those are x-intercepts, right?
Do we like
Do you
reverse
know
order?
maybe where your vertex or
No,
axis
right.
is ID in respect to that?
We can go ahead and draw a graph.
Oh,
It's not exact.
She gets
So-
all day at church.
You know
But we can
age,
put it at table.
negative 3.
Put the little arrows on it, so we know it goes on forever.
How could you find?
So. What are the values? What is the value?
That's my
My
input.
mom had that yesterday. I was with her.
Stop.
It was good to get in.
Let's think.
Use that.
What value is in
Well,
the?
You go to
But
church,
that
I
ain't
got sweet.
it.
Yes,
My dad
I
Pretty thing. Right out.
Also, let's fix our.
Martin.
Because 0, negative, you did 2, 0, and 4, 0. It's not 2, it's.
How do you?
I got my Lord knows she get talking but get a class again.
You don't have
No, what
to 0, but positive 4, 0.
She get the.
Do we distribute?
Do you have your table?
I got
Yeah, I do, yeah.
Okay, we got a winner.
Oh, no, we don't, no, we don't, no, we don't, no, we don't.
So, what?
We do not.
We do not?
No, look at the table.
Oh, yeah, sorry, just kidding, keep working, we're almost there with a group.
Look at that table.
Well, you don't need to distribute, do you know what negative 3 plus 2 is?
sunrise to sundown.
Close. What's negative 3 plus 4?
Get it.
I don't want you to get it done.
You're singing.
What's up?
I need help.
Why?
What that kid.
My feet hurt.
I don't think I'm doing it right.
You are.
I am?
Yes.
Okay.
You don't, well, you don't, you do f of negative 3. And so. It's 2 times negative 1.
Negative
Times 1.
2. Negative 2. So it's down.
This is just
Okay.
procedural.
That input,
It never
is that
flattens
output?
out.
So, one thing I would point out is, I would, so vertex is in the middle, right? So,
Now,
we're gonna go here.
Mr. Kenny, we kind of have a tie.
Okay.
2, 0.
You fixed it right as they got.
I realize I put negative 4,
So you guys are tied.
But, alright,
They fixed it right as they got there.
alright, so let's talk about this one. Cause I gotta talk quickly, we got 4 minutes, I need to talk about 2 things. First things first, guys, x minus r1, I need the what of that plus 2? It starts with an O.
Opposite.
I need the opposite. Negative 2, 0, negative 4, 0. And guys, right here and right now, I need y'all to pay attention to this. Okay? So where's my vertex going to be for that? Right in between. So notice, what is H? Notice how I called it H because I'm looking for my vertex? H has to be a negative 3. Right? And remember, this H is also a what, Aiden? An X or an input. So Aiden, where am I going to put this in? For what? For X. Q of negative 3 equals 2 times negative 3 plus 2 times negative 3 plus 4. Now, who was it? Lane, you said a good thing of like, oh, I know it has to be concave up, but be more precise. We know this input has to give us an output. So Q of -3, notice that's H. That's going to be -1, that's going to be 1. Someone, by the way, eyes and ears, asked, hey, do I need to distribute? Distribution is when we cannot simplify. Can I do -3 plus 2? Yeah, so simplify. That's my K. -3, -2. Now if I want a table, I just pull from that. So, -4, 0, -3, -2, -2, 0. Hey guys, stop hacking. You got a test tomorrow. Now, if I wanted to get the output, or get this Y, or get this Y, what could I do? What's this -1 also called? An input. So what can I do? Input it. Put it in for X. Okay? Pay attention to those details. Last couple of things that I do want to point out here because we didn't have time. Hey, since we found our vertex, could I convert this to vertex form?
Yeah.
Now, are you going to have to find the vertex for the test if it's in factored form? No, that's the exceeds portion. In factored form, I just need concavity and roots, but that can be extra information. But now I can convert this to x plus 3 squared, and then my k was -2. However, are we going to expect you to go from factored form to standard form? Yes. Yes. Who remembers how I can go from factored form to standard form? That little area model, the box. Remember, that area model helps me multiply. I start with my factors, the variable factors. X times x is x squared. X times 2 is 4 times x. And 4 times 2. And so I'm left with, these are like terms that I'm adding, x squared plus 6x plus 8. And then I still have the 2 that I do have to distribute now. My guess is that we are going to get farther in my third block, so I may be adding some to the video from just today. Guys, you don't need to watch the parts of the video where y'all are working, but when we're going over stuff up here, I would highly suggest that some of you watch those videos to prepare. Yes, go ahead and shoot. There we go, 3 points. So, Tyler's group gets candy. Kayla, Bree, and Mason, come grab candy.
Yeah, 9's also good because we cut it. So, yeah, we both just.
Okay. So,